Good afternoon. Okay, so far in the previous classes we have seen how to write queries using SQL, and then we have seen relational algebra and relational calculus, by using which we can again retrieve information from the relational model. So from today we'll see functional dependencies and normalization. So why we are going to learn this functional dependency and normalization? From the very first class, I told you that if we are having database, then what we need to do is, means even the database also, it should satisfy all the properties of database. Okay, that means the database integrity and then the consistency should be maintained whole throughout the use of that particular database. Okay, so the database should maintain integrity and consistency, and other than that, they should be also able to this one recover from failure, and then they should be able to control concurrent access of the database, and also they should be able to control transactions. Okay, all these things, all these properties of database management system, they should means the database should have this property. The database should possess these properties. If for that we were learning the constraints, isn't it? So in order to make our database is consistent and to maintain the integrity of the database whole throughout the life of that particular database, we were applying constraints while designing the database, like constraint like domain constraint, foreign key constraint, entity integrity constraint, and other remaining constraints. We applied them in while designing the database in order to get the properties of the database. Okay, so if we do not, means if there is this one, if there is something that missed out while designing the database, then what will happen is, after using the database, at some point of time, you are going to, the user of the database, the end user of the database, is going to face some problem. Okay, so those problems, like there are some few problems that we need to see for that, and means anomalies might arise after using the database at some point of time. And there are three types of anomalies that can be there in our database if the design of our database is wrong. Okay, if the design of our database is wrong, and if some constraints is missing when we are applying constraint during the design phase, if some constraint, if we missed out to apply some constraint, then three anomalies may arise while using the database. Okay, those three anomalies are insertion anomalies, deletion anomalies, and updation anomalies. Okay, there are three anomalies is that may arise if your design is wrong. In a simple word, if your design is wrong, then at some point of time after using the database, three anomalies may arise. So those three anomalies I will tell you, means before going to this functional dependencies and normalization, I will just go on these things, and then after that, why we are learning about functional dependencies and normalization, I will tell you later on. So these three anomalies, I'll tell you one by one. The first one, insertion anomalies. So insertion anomaly, for example, let's take the example database, that is company database. If the design, whatever relational model, entity relationship model that we are seeing so far for the company database, they are all correct. Okay, they have all the properties, they possess all the properties of database management system. But if, say for example, if the department relation and the employee, okay, they are in a single, okay, if part employee information are stored in a single table, then what will happen? That is going to be a wrong design. Okay, if the department and if information about department and the information about the employee, they are combined in a single table. Okay, then that is a that is not a good design. But if it is means if we have such kind of table, then what will happen? I will tell you. The first one is insertion anomalies, isn't it? So what will happen if there is a employee join as a new employee? If a new employee join and the company haven't allotted any department to that particular this employee, then what will happen is the department and DNO value is going to department information is going to be having value null. Okay, department information is going to have null because he or she is not yet allotted to any department. Okay, but you need to remember that every table needs to have a key, isn't it? If the department and the employee table, they are combined in a single table, then what will happen is the employee SSN, the combination of the employee SSN and the department number is going to be, DNO is going to be the key. Okay, even if you did not take the DNO value as a key, then what will happen is all the value of the department information, all of them is going to be null. Okay, if few more employee joins and if they are not allotted to the department, then all of them, the entire information about the department is going to be having null values. Okay, and in a table which is having a very means which is having a very huge amount of null inside a table as a value for attributes, then this is not a good thing. Okay, so that is one problem, insertion anomaly. Another insertion anomaly, I will tell you what will happen is if there is a department, say for example department number one. Department number one means for this particular department number one, the name of the department can be the name of the department is going to be having, say for example, CSC, and then other information about the department, say for example department manager SSN, department manager start date. We have all those things, isn't it? So if there is 1,000 employees in that particular department, then for those 1,000 entries, the information about that particular department number one is going to be entered for those 1,000 entries, isn't it? Again and again. So again, there is a redundant data there. If there is a redundancy, then at some point of time, if the SSN is the primary key, then what will happen is there while entering any of the employee detail, a mistake may happen, and say for example in a tuple the department name for department number one is CSC, and in certain other tuple the department name of the department number one can be ECE, because while entering the value there is a mistake done by the particular user. Then kind of that kind of problem might arise, okay, because of redundant data. So those are two things that is included in your insertion anomalies. So those things are known as insertion anomalies. So while inserting, anomalies are created, problems are created. Okay, so if the design is wrong, if you are having a wrong design, if certain constraints are not applied on your design, and then what will happen is these anomalies may arise as while using the database. Okay, so that is insertion anomalies. Same thing, deletion anomalies. I will tell you one example of deletion anomaly. If there is a department, say same department CSC is having department number one, so those things are there. If say for example this particular department is having a single employee, okay, this particular department is having a single employee, before recruiting the other remaining employee, if this single employee is, say for example he or she quit, okay, or he or she this one is retired, then what will happen? You need to delete the information of that particular employee, isn't it? While deleting the information of the particular employee, the information about that department will also be deleted. But still, the department is there in the company, isn't it? Because there is no more employee in that particular department, and the information about the department is not there in our database. So that is a deletion anomaly that may arise if your design is a wrong design. Okay. And the last one, third one, updation anomaly. Same thing, updation on anomaly also. If you want to uh, update the manager SSN of a department, okay, or manager start date of a department, then you have to update for all the entries of the employee belonging to that department. Okay, you need to see the company database for this, whatever I'm saying. So in the department, if you combine the department and employee table in a single table, then, and in the department table, you know there is a manager SSN, isn't it? If the manager is changed for that particular employee, for that particular department, then for all the entries of employee who is belonging to this department needs to be updated with manager SSN again and again. And again, that is also because of the redundant information we stored in the table about the department. Okay, so that is updation anomaly. So these three anomalies may arise if we have a wrong design. Okay, so that is why I'm saying from the very first beginning of this class, I'm telling you guys to design your database properly with applying all the required constraint in your model, in your design. Okay, so that is one thing. If why now I'll come to the point, means I'll come to this functional dependencies and normalization. If the database is a huge database, okay, if your design is a huge one, and if you are not able to make sure that your design is correct or not, okay, you are not able to means you are not able to this means able to get the means if you are not able to say whether your design is correct or not, then what will happen is you can use normalization for that. Means for every design for a model, it is going to be a relational model. Okay, if you have a relational model and if you want to check whether it is a correct model or not, then you can check for certain normal forms. You are going to check for certain normal forms. Means whether the relational model is in this normal form or that normal form. There are many types of normal form. We will come to that later on. Am I audible to you?
Yes, ma'am.
Can you see my screen? Means there is a loss of connection in my side, so that's why I'm saying.
Ma'am, you just stop sharing.
Okay, so wait for a minute. Okay, can you see now?
Yes, ma'am.
Okay, so you will be having a design, you will be having a relational model. So for those relational models, checking for certain levels of normal forms, there are certain levels of normal forms we have. And those certain level of normal forms, you are going to check if it is not in a proper normal form. Okay, if it is not in a proper normal form, then you can use normalization in order to bring to the proper normal form. Okay, so normalization is the process of making your design a wrong design to a correct design. Okay, So if you're not sure about your design, then you can use the method of normalization in order to make it a correct design. So that is why we need to learn the normalization. Now, what about this functional dependencies? So functional dependency is a tool. Functional dependency is a tool for the process of normalization. So whenever we are performing normalization, we are going to use functional dependencies between the attributes. So dependency, this is the dependencies between the attributes, okay, of a relation. So this particular thing we will be using as a tool for doing the normalization process, for performing the normalization process. So we need to first learn about functional dependencies. After that, we'll go to the normalization. So this functional dependency, I'm not giving about the anomalies and all. So you have to means all the this modification anomalies that may arise because of a wrong design. You can check it from the web. You can find it insertion anomalies, deletion anomaly, updation anomaly. You can find it in your textbook also. Okay, so you need to read it once in order to understand what is means what is happening there in the anomalies, how the anomaly arise and all those things. So I'm not going to give it here. Okay, now let us see the functional dependencies. Functional dependency, here this is a definition of functional dependency. This is a formal definition of functional dependency. I will just read it out. After that, I will explain. So functional dependency is represented like this. So X is a set of attributes and Y is also a set of attributes. Can you see my screen? Again, it is, again, I lost the connection.
Not anymore, ma'am.
Okay, so functional dependency is represented like this. You can see here X arrow Y. So X arrow Y here, X is a set of attribute and Y is also a set of attribute. Okay, X is a set of attribute and Y is also a set of attribute. And this is, I'll just read it out first. Between two sets of attributes X and Y that are subsets of R. R is going to be the set of attributes of a particular relation. Okay. Subsets of R specifies a constraint on the possible tuples that can form a relation state R of a R. Now you remember about relation state, isn't it? What is a relation state? Anyone tell me? What is a relation state? Do you remember relation state, relation schema? What is a relational schema? You have already given your midterm and you do not know a relational schema and a relation state. Relational schema is the name of the relation along with the name of the attributes, isn't it? So that is a relational schema. Whatever I'm giving you, whenever we are writing a query, whatever I have given to you in the question, that is a relational schema. You have the name of the relation along with the attributes, isn't it? I already told. And a relation state, what is a relation state? Do you remember now? A relation state?
Is it a set of tuples?
Yeah, it is a setup. It is a setup tuples in an instant of time. Okay, so it means you will be having your tables, and you will be inserting data. So you will be inserting tuples in your relation or in your table, isn't it? So at an instant of time, you might be updating, you might be doing updation, you might be deleting, you might be inserting, you might be doing so many things. So in a particular Do you get it now?
Yes, ma'am.
Say this here. You can see here. This is a relation state at a particular point of time. We have the attribute names. Name of the table is not here, but just think name of the attribute is employee. It is going to be employee. So just think an employee is, you already know the name of the table. So this is the name of the attribute, and these are the tuples. These are the values. So this is a relation state. If you remove this information, these tuples, all these tuples, this have 5 tuples. So if you remove all these tuples and you have a name of the, you only have the name of the relation along with the name of the attributes, then it is a relation schema. It is a relational schema. Okay. So what is means what it means is the constant. There is a constant. So the constant is that for any tuple T1 and T2, for any tuple T1 and T2 in R is a relational set. Okay, here you can see relational set R. You can see it is a set. It is going to be a relation, but at a certain point of time, whatever tuples it has, so that is the thing. So it is represented by the small letter r. The constant is that for any tuple T2 in R that have T1x equal to T2x. Okay, if for the tuple T1, if we have 2 tuples, for example, this is only for a single table. Okay, whatever we are defining for the functional dependency, it is for a single table. So in a single table, there is two tuples, tuple T1 and tuple T2. In tuple T1, the value of attribute x, and in tuple T2, the value of attribute x, if they are same, then the value of y in tuple T1 and the value of y in tuple T2 should be same. Okay, if there is a dependency between x and y. If there is a dependency between x and y, or you can say y depend on x, or y can be determined from x. You can read it like this. Y functionally depend on x. You can read it like this, or y can be functionally determined from x. Okay, if this is true, if there is a dependency like this between x and y, then this should be true in a particular relational set. Okay, so this is the formal definition of functional dependence. In simple words, I will just tell you. If the value of x is given, you can be able to determine the value of y. This is a simple definition of functional dependency. If there is a dependency from x to y, then the value of x can uniquely define the value of y. Or you can say the value of y can be determined from the value of x. What does it mean? If the value of x is given, then you will be able to get the value of y by looking at the particular relational set. Okay, if there is a dependency between x and y. So you can see here also I have given this simple definition. The values of x components of a tuple uniquely or functionally determine the values of y components. Okay, so this is a functional dependency between two sets of attributes. Now I will ask one thing. If say for example, I'll remove. If this is an example table, it is an example relation at a point, at an instance of time, if we are having all these values, then you can say that by looking at the values, you can say that if here you can see F's name are all unique. Tom, Jerry, John, Alice, Bob. Not one of them does have a similar value. Okay. Another thing, that means if the value of the F name is given, then you will be able to determine any of the other remaining values of the other remaining attributes. Okay, same thing. Say SSN is also unique. You can see SSN is also unique. So if the SSN value is given, then you will be able to determine the values of the other remaining attributes. Okay. What about DNO? DNO you can't mean if the value of DNO is given, they are not unique. You can see tuple this one and this one is having the same DNO value, and these three are having same DNO value. So if DNO value is 2, then you will not be able to determine the name of the employee. If DNO value is means there are two values of F name if DNO value 2 is given. It is either Tom or Jerry, so you are not able to determine, isn't it? So in an instant of time, whatever values we are having for the attributes, if they are able, but you can see here one thing. No, there is no department name. Okay, so that means what you can conclude from here is you can conclude few things. You can conclude few things. If the SSN value is means by using the SSN value, you can uniquely determine the value of FNAM. If the value of SSN is given, you can uniquely determine the value of birthday. And again, if the means combination of SSN and along with any other attribute, you can determine the remaining attributes. Okay, so that means if this is means this X, this particular X here, if it contains the key attributes, if it has the key attribute here, then means as a means it is going to be a set of attributes. If your key attribute is a part of this X, then you will be able to determine all the other remaining attributes. Why? You will be able to determine any of the attributes. So that is always going to be true. Okay, the functional dependency between the key attribute with the other remaining attribute, they are always going to be true. So that is why I have given some of the functional dependency that we can got from this particular table. So SSN functionally determine FNAM, SSN functionally determine birthday. Combination of SSN with any of the attributes can determine other remaining attributes. Even it can also determine other remaining attributes also, isn't it? This is this we already know. If the value of the key attribute is given, you can determine the other values. So this is for the employee table. If you have some table like this, if you do not know even the key, if you are not able to determine which attribute is going to be the key for this table, then what will happen is you can use functional dependency. Okay, now let us see. From here, according to the definition of functional dependency, what it says is the constant is that for any two tuple T1 and T2 in R that have T1x equal to T2x, they must have T1y equal to T2y. In some few tuples, if the value of x is same and if the value of y is same, then you can say that there is a functional dependency between x and y. Okay, now let us check this one. Value of x, if it is 1, then the value of y is 4. Value of x is 1, value of y is 5. So you can't say x can determine y. Now what about y? Value of y, if y is given as 4, then it is going to be, x is going to be 1. Value of y, if it is 5, then it is going to be 1. 6, it is going to be 1. If it is 2, it is going to be 3. That means you can determine that value of x if the value of y is given by looking at this functional step, this relational step. Okay, because you are having a unique values of y. Okay, same thing if the value of z is given. You can see here if the value of z is 2, you can see two tuples for value of z equal to 2. Then you can't, means they are not same. Y is also different. You have a different value of y, and even value of x is also different. So you can't determine it, both of them. Now by looking this relational set, tell me which of this following four is true. Which of the following holds this functional dependency? If you combine x and y, you can see if you combine this x and y.
Number 4.
Number 4. Let us see this number 4. So this one. X, z determine y. So the value of x and z is going to determine y. So if x and z is having 1, 2, then the value of y is 4, okay. If x and z, combination of x and z is having 1 and 3, 1 and 3, then the value of y is different. You can see here. Y is different. One is having 5 and one is having 6. So this is not true. Okay, this is not true. For certain tuples, means if there is 2 or more tuples which is having the same value of x, z, then the value of y should be same. Should be same. That is the definition. Okay, so this is not true. Let us check for this one. Y can determine x. This is true for, because we already know this is true, because the value of y is unique for each and every tuple. So this is going to be true for sure. Okay, let us check the other one. So this is not correct. Okay, this is not, does not hold. We already check it. Now let us check the other remaining things. X, Y determine Z. So combination of X and Y determine Z. This is going to be true. Why? Tell me anyone. The combination of X and Y can determine Z.
Because y is unique.
Yeah, Y is unique. So combination of a unique attribute with any other attribute can determine the remaining other attribute. So this is always going to be true. So this is true. Okay, what about Z can determine X?
No.
No, it is not true. It doesn't hold. Okay, so if does this number 1 also does not hold. Okay, now what about this? Combination of Y and Z can determine X. This is going to be true because we are having Y in the left hand side. Okay, what about Y determines Z? Yeah, this is also true, isn't it? Because Y is having unique values, so it holds. This. Okay, this is true. This one, the last one, third one, Y, Z can determine X. This is true, but X can determine Z is not true. You can see here when the value of X is 1, 1, 1, 1, the value of Z is 2, either 2 or 3. So it has two values. They are not same. Okay, so it does not hold. Okay, so like this you can find the functional dependencies. So this is, if you can see here, the constant is that for any two tuples T1 and T2 in R that have T1x equal to T2x, they must be T1y equal to, means they must have T1y equal to T2y if there is a functional dependency between x and y. So this is one thing you can see from the relational set, and you can determine functional dependency. In another way, the value of x component of tuple uniquely or functionally determine the value of y component. That means if the value of x is unique, means if it is unique for each and every tuple, then it will be able to determine all the value of y. Means if y is having all the other remaining attributes, then it is going to be true. Okay. So here. Okay, now this here, tell me any functional dependency that you can find out from this particular relational step. Okay, let me copy this. Okay, tell me. Functional dependencies that hold for this given relational step.
AB can determine C.
AB determine C. Let me see AB. Okay, B is having unique values, so it is going to be true. AB can determine C and also can determine D. Okay, because it has B here in the left hand side, and B is unique for each and every tuple. Okay, so this is true. Other things?
A determines
Anyone?
C.
Ma'am,
Yeah,
any
A
combination of
determines
B like A, B, C, B, C can D or A.
yeah, if you have B in the left hand side, if you have B in the left hand side, even only B also, you can see A, C, B. So even only B also, you will be able to determine the value of A, C, and D. Okay, because the value of B is unique. And if you combine B with any other remaining attribute also, the other remaining attribute you will be able to determine. Okay, because B is having unique value for each and every tuple. This is going to be true all the time. Now tell me any other, is there any other remaining functional dependency that we have here?
Ma'am, can we also use CD together and determine the other two?
Yeah, you can use CD also. Tell me. CD?
Okay, but CD can determine any of the other two or both of them together.
Yeah. A, B. Because the combination of CD is also unique, isn't it? CD, 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 they are all unique. So you can determine A and B from there also. Okay. Any other?
Ma'am, can you write B, C, D to A?
B, C, D to A. Let us just write it down and let us check it. B, C, D. Okay,
And
they
D
are
in the
also
left
unique
side, then
because
any combination
this
can
already
follow.
know. We already know because B is there. Okay, in the left hand side, and we know B is always unique. Okay, so this is going to be true. Yeah.
AD, ma'am.
Who was saying? Huh?
AD in left side, ma'am. AD to BC.
AD to BC. Okay, that is also true. AD BC. AD BC. This is also true because they are all unique. Okay, so this is how you can determine the functional dependencies of a given relational set. So you can determine many functional dependencies. Okay. Now you already know what is the definition of functional dependency. Now what things we can do by using functional dependency, we'll see those things in the next class. So how we are going to use functional dependencies for normalization also, we'll see in the later classes. If you have any doubt, then you can tell me. There are many things we can do with functional dependency. Okay, so you need to make sure you understand the definition of functional dependency. This is very important. Okay, functional dependency between different attributes. So how to find it? You have to know that. You should know what is a functional dependency in order to understand the remaining classes of functional dependencies and normalization. Okay, let me take your attendance.